Find three consecutive terms of GP whose sum is 13 and sum of whose squares is 91. So we will have to imagine or assume some three terms of AP. Let the first term be A. Second term obviously would be AR, and the third term will be AR square. Three terms are there. Sum of these is 30. Now, the sum of the squares means A square plus AR square plus AR square and whole square is 91. So we can solve it further. A square plus A square, little proper, A square and R square plus AR square. So A square and R to the power 4 is equal to 91. Keep it as a second equation. Say second equation. Now we have to have a relation between all of these. So what I'll do is I'll just put it here. That is, take first equation A. We have to have a common relation between the two. I can't have it until unless I make a square of this one here. So see, A plus AR plus AR square is 13. Now see, if I square them both the sides, it will become A square and something. Then I can have a relation between the second equation. So this is what I'm doing here, squaring both the sides. Square LHS, square RHS. What do we get using the identity? A square plus A square R square plus A square and R4. You know how it is. So then plus 2AB. Remember, is A plus B plus C the whole square. A square plus B square plus C square plus 2AB plus 2BC plus 2CA plus, right, like that. So it has to be 2 times A, right, and AR plus 2 times AR and AR square. Okay, plus 2 times AR square and A. Okay, now after that we have to solve it. So I'm coming here. So it will be A square. Now this is equal to how much? 13 square. So now we write here A square plus A square R square plus A square and R to the power 4. It has a value, you can see I have kept it here same. Now plus I can solve it. It will become what? 2 A square R, right, plus 2 A square R cube plus 2 A square R square, and this is equal to how much? 169. Okay, now further, now I know the value of this one, which is there. A square plus AR square, A square R square plus A square R4 is how much? 91. So I can write 91 here. Okay, 91 plus, here I can take something common in it. What I can take common is, I can see it has got AR in it, right? I can take 2 common, and A square I can take common, or I can take only A common and R common here, right? What is left? Let's see. A plus AR square plus A square R. I have taken A common, right? Should not be as such because it should come as A. So I made a mistake somewhere, I believe. No, A square and BA, right? So it is this. If I take here A square common, then what will happen? If I take A square common, it will be R only. This will become R square and this will become R only. So it will not help you. So if I take this, it is A plus AR. I'm not getting. Oh, okay. Here it is. A is common. Second, it will be. Oh. So here, if I take here A common from the third one, it will be A only, right? A and R. Okay. Fine. Is equal to 169. So it will be 91 plus, let me rearrange this, 2AR. It will be A plus AR plus AR square is 169. So it will be, I can move this 91 the other side. It will be 2AR. A plus AR square is what? 13. You can see the first equation. So I can put here 13 and is equal to 169 minus 91. So it will be 2AR, okay, is equal to, if I subtract 91 from it, 9 minus 1 is 8 and say 9, so minus 1 is 8, 16 minus 9, 7, so 78. And if I further solve it, AR will be equal to 78 by 2 is equal to how much? Oh, there's a 13 more in it, into 13 also. Okay, I wrote it. And 13 also. Why 13? Because this 13 is here. I forgot to write 13 into 13 here. So let me write it. Small error and you are gone. So this is 13 into this. So 6 and it will be 3. So AR is 3. We got AR as 3. We can keep AR as 3 and also we can keep A is equal to or R we can calculate, right? Because R is needed. So R will be 3 by A in it. So any one of these can be used now. See how do we use it in the question. Now it's not yet the answer we have got. We have got simply A, R here. Sum of the whose, okay, we have to find 3 consecutive terms of the 3 consecutive terms. So 3 consecutive terms would be like, say, we have got, first one is, see, we will take the first equation that we had, A plus AR is equal to 13. So write it here. A plus AR square is 13. Now what is A? A we do not know, so write it A only. I substitute for R only. So what is AR? 3. What is AR into R? I can write 13 here. So I can write here A plus 3 plus, what is AR? AR is again 3 and R is 3 upon A. Solve it. So A plus 3 plus 9 upon A is 13. Make it A here all the side, all the say, make it A for all of those. It will become A square plus 3A plus 9, this is 9 here, the whole thing upon a is equal to 13. So solve it. A square, a square plus 3a plus 9 is equal to 13a. Come on. Here. So a square minus 10a plus 9 is equal to 0. So you have to think of a number whose product will be 9 and sum will be minus 10. Can you think of a number? Just 1 second. Why can't we think of a number? Yes, we got a number here. So it will be 9 into 1 minus 9a minus 1. A is plus 9 is equal to 0. So a common, a minus 9, okay, and minus 1 common, a minus 9 is equal to 0. So a minus 9 and a minus 1 is 0. So which means a is 9 and a is 1. So we have to get the GP here using the 2 separately. So when a is 9, the AP will be 9 and AR. So R we have already got as how much? What is R in? I'll just write R is equal to, R we have got it as here. R is 3 upon A. So R is 3 upon 9, which is 1 upon 3. Okay. So the next one will be what? AR. AR we already have as a 3. AR is 3. Right? So 3. And the third one will be AR square. So AR square is what? Okay. See, this is for A. This is for AR and this is for AR square. So that is AR into R. So AR is 3 and R is 1 upon 3. So that is what it will give you 1. So we can write it directly as 1 here. So the GP is 931, and if you take the other one, that is A is equal to 1, so it will come as 1, 3 and 9. Always reverse it, you will get the same answer. So these two are the GP and as an answer here. This is also the GP and this is the answer that we have in it. So remember, it's a long way down that you have to solve it. It's a difficult question, but yes, this is how we can solve it.